Okay, so it's 4:30. We're starting with this problem about inverses, following up what we did last time. We want to know what is the inverse of x minus 1 divided by 2, and you have 4 options. So take a minute and a half, if you haven't yet, and try to figure out the inverse. Okay, 10 seconds left if you haven't put in your guess. Okay, let's see what people said. X minus 1 divided by 2 inverse. People said, ooh, pretty even split between the first two options, 2 times x plus 1 and 2x plus 1. These are both very reasonable, and for sure it's one of these two. Let me tell you why for sure it's one of these two. We are looking at the function. Screen is frozen. Okay. How's that? Okay. Still frozen? Okay, that one works. This one says it's not frozen. Okay, now they both work. Okay, great. So the only problem, I guess, is people who need the code. Does anybody remember what it was? Let's BP. And let's put this back. Go freeze that. Oh, okay. See, there's some kind of bug where you press 1 and it freezes both. And now neither are working? Okay. Now one of them is frozen, but that one isn't. Okay, which is what I wanted. On my screen it says neither are frozen, which is wrong. Okay, BPFG. BPFG. Okay. GF, thank you. Is it actually GF? Yeah. Okay, so let's try again. Let's try again. So the two options people chose are these ones, 2x plus 1 and 2x plus 1, which when you say them out loud sound exactly the same, but of course they're different because the brackets are different. One of them is 2 times x plus 1, one of them is 2x plus 1. So they're different, and they both involve multiplying by 2 and adding 1. And why is that perfectly reasonable? Well, what function did we do? We did the function x minus 1 divided by 2. So the function we did is working out, okay, is the function f of x is x minus 1 divided by 2. What is the function x minus 1 divided by 2 doing? I think it's actually doing two things. First, you subtract 1. So you feed x through the minus 1 machine, and you get x minus 1. Oh, gentleman in the back, you're blocking the projector. Oh yeah, try again, okay. Was there a question up there? Question or comment from the corner? No? Okay. So first you subtract 1, x minus 1, and then you divide by 2, right? Divide by 2. Divide sign 2, and that gives you x minus 1 divided by 2. So the function we are looking at is a combination of subtracting 1 and dividing by 2. So of course the inverse, f inverse of x, is going to be a combination of plus 1 and times 2. Why is it a combo of plus 1 and times 2? Well, if you want to undo subtracting 1, you add 1. If you want to undo dividing by 2, you multiply by 2. So of course, we're going to combine them somehow. And the question is, how do you combine them, right? Do you do x plus 1 times 2, or you do x times 2 plus 1? What order do you put them in? And that is essentially what you guys have chosen here. These are the two options. In this one, you add 1 first, then you multiply by 2. In this one, you multiply by 2 first, and then you add 1. And what is the correct answer? Well, it's split pretty 50-50 between these two. So I will let you guys think about it, try to figure out which of these two it is and why, and maybe this will help you, the order that things are in here. Try to figure it out, and then I will take it up in another minute. So let's revote one more time. And I'm gonna make a copy, and you gotta put your answer in again. So think about it, and we'll try it once more in 2 minutes. Oh, that's the wrong thing I want. Okay, well, we're up to 60 votes, so maybe I don't need the full 2 minutes. Let's just do another 20 seconds. If you're like one of the last 4 people here who hasn't put in your answer yet, you have 10 seconds left for the last few people, because it seems like most people knew right away which one they were going to pick. Okay, let's look now in the updated vote. Lots of people put in their answers quite quickly, so maybe it was obvious to some people what the right thing should be. Okay, it's still pretty split. So 41 to 28 out of 70 people, although I guess 2x plus 1 is taking a very slight lead. So here's the question, how do you figure out the right way to do it? I'm going to explain it the way I explained to my 3-year-old son, using an example of putting on your socks and your shoes. So let's pretend F is put on your socks and your shoes. So first you put on your socks, put on socks, right? So this is you with nothing on, and then you go in the machine and out you come, and now you are wearing beautiful pink socks, okay? You put on your socks, and then you put on your shoes next. Put on shoes. Oh, I don't want black, I want the same color. Well, okay, we're doing it in black. I guess you're putting on black shoes. Put on shoes. Shoes. So what comes out is you in your socks and your shoes. Okay, good. These are your pink socks, and you're wearing beautiful black boots over top. Okay, so you've put on your socks and you put on your shoes. That's the order we did them in. First we put on our socks, then we put on our shoes. Just like over here, first we subtracted 1, then we divided by 2. How do you undo it? You put on your socks, you put on your shoes, then you get home at the end of the day. How do you undo that? Which order do you do it in? The order you do it in is shoes off first. Shoes off first. That's what you have to tell my son. Shoes off first. So the reverse of put on your socks, put on your shoes is take off your shoes, off shoes, and then off socks, right? So here's our little setup is like this. And I think that is perfectly intuitive, right? If you want to undo putting on your socks and putting on your shoes, you have to first take off your shoes, then you take off your socks. In our particular problem, it's not socks and shoes, it's -1 and divided by 2. So how do you combine them in the right way to undo it? Well, you do the last thing first. So instead of dividing by 2, you have to multiply by 2. So times 2, and then whatever comes out of that, then you do +1. And it's exactly the same thing as before, right? You got to undo them in the opposite order that you did them in. So -1 divided by 2 times 2 plus 1. And that function, if you start with some value x, right? You feed in x, what are you going to get? Well, multiplying by 2, you get 2x. And then adding 1, you get 2x plus 1. So 2x plus 1 is the right answer because you have to first undo the last thing you did in the same way you do it for socks and shoes. So how many people got it right? 58% of people got it right. It is 2x plus 1. Hopefully that description made sense. It's the same analogy as socks and shoes. You got to undo them in the opposite order you did them in. Questions and comments about that example? So this is how you undo things. The other way you could check, if you had two options and you weren't sure, you could feed in some particular x value. So what if you did like x equals 3? If you did x equals 3, then x minus 1 is 2, and x minus 1 divided by 2 is 1. So f of 3 equals 1. What happens when you feed in 1 over here? So you feed in 1, you get 1 times 2 is 2, and then 1 times 2 plus 1, 2 plus 1 is 3. So it works perfectly well. Whatever got fed into the first machine, the other machine does the opposite. The inverse does the opposite, so it's all working very well. Everything I've done so far is literally exactly what it says on this page, page 195. So at the bottom of a page 195, it has everything I've just said listed in words. So consider the function x minus 1 divided by 2. We take an input x, subtract 1, and then divide by 2. Those were the two steps we did. The reverse rule would be to multiply by 2 and then add 1. And again, the order is reversed the same way they are for socks and shoes. So f inverse of x is 2x plus 1. That's what we just did. And there's the example. F of 3 is 1, and f inverse of 1 is 3. So if you understood this, the next thing we're going to do is learn how this works in terms of algebra. So how can we do everything we just did using algebra and kind of make it less about words and writing sentences and just do algebra steps to get the right answer. But if this doesn't make sense, then the algebra steps are just going to be like mumbo jumbo. So good chance to ask. Questions, comments? Okay, so let's see how to do it with algebra. That's exactly what's on the next page. So this is something we saw last class. The functions undo each other. The domain of the function is the range of the inverse function and vice versa. Here's the socks and the shoes. And here is what I want to get to, algebraically determining f inverse from f. And this is on page 197. So to algebraically determine f inverse from f, perform the following steps. We replace f of x with y. And the only reason we do that is to make the notation easier. And so basically this is because y is easier to write than f. And we're going to be writing them a lot. So this step is really just to make things convenient to write. Step 2, swap x and y. Swap x and y. Now this step to me, when you see something like this bothers me a lot. Because it's like, why? We just replace x and y? Who said we could do that? The reason we're replacing x and y, remember, is that if we're writing f inverse, we want to get to y equals f inverse of x. This is what we want. And if y equals f inverse of x, because f and f inverse are opposites, that's the same as saying that f of y equals x. So if we want to solve f inverse of x equals y, this original thing, then we have to have it in the form f of y equals x. And normally, we write y equals f of x. So because this thing is backwards, that's why we're swapping the x and the y. Right? We started with the f function, we want the f inverse function, but they're backwards of each other. Step 2 is applying our own backwards to it so we can get the final answer. So that's why we're swapping them. It actually makes perfect sense. As soon as you swap the x's and the y's, now you are in this equation, y equals f inverse of x. Whereas before, you were in the opposite equation, f of x equals y. All right, that's step 2, which is a very counterintuitive step. I know a lot of people just like to memorize it and do it, but I like to understand why we're doing it. Step 3 is solve for y. And how are you going to solve for y? To solve for y, you are going to have to undo all the steps, all the operations of f. And you're going to see that in a second. Right? So f does stuff to x. To undo it, we're going to be able to solve for y. And this last step is literally the algebra version of what we just did with the dividing by 2 and adding 1 in the first example. So this is the algebra version of rearranging the boxes, say. Okay, let's see an example. And the example we're going to do is the example we just did. We're going to do it with algebra instead. So f of x is x minus 1 divided by 2. Step 1 says, let's write that is y equals x minus 1 divided by 2. So step 1, we replace f of x with y. It's just easier to write. Okay. And again, this is the equation, y equals f of x. Okay? That's all we've done. This is maybe like my ideas over there. Step 2 is we swap the x's and the y's. So we have x equals y minus 1 divided by 2. And again, don't confuse yourself. What we've done by swapping it, now it's the equation x equals f of y, and the equation x equals f of y is exactly the same as the equation y equals f inverse of x. So that was why we swapped it. We wanted the x to go inside the f inverse, and that was why we did step 2 of swapping x and y. X and y. Okay. And now we do algebra. Now we're going to do algebra steps to rearrange for y. This equation right now has the y buried inside a bunch of algebra. We're going to do algebra steps to isolate for y. So how do we do algebra steps to isolate for y? Well, there's a divided by 2 on the right-hand side. So why don't I multiply both sides by 2? I get 2x. So this is multiply by 2. Okay? And then now there's a minus 1 on the right-hand side. I don't like that, so why don't I add 1 to both sides? Add 1 to both. Okay, and we finally gotten to y equals 2x plus 1. That is the equation. Y equals 2x plus 1 is exactly what we're looking for. Y equals f of x. And so we have, if y equals 2x plus 1, f inverse of x is 2x plus 1. And then we're done. Very nice. And you can see what were the steps we had to do to undo, right? To undo, this is step 3. Solving for y, we had to multiply by 2 and add 1. Those are exactly the 2 steps we had to do to undo the action of the function f. F was subtract 1 and then divide by 2. So to undo it, we multiply by 2 and then add 1. So that's the algebra version of what we just did as the warm-up problem, finding the formula, this time with algebra. Any questions or comments about that one? Okay, let's see another one. Let me freeze this one for people who are stuck on it. Let me make sure it's working. Okay. Okay, the next example is this more complicated function, x plus 4 divided by 3x minus 2. Okay. X plus 4 divided by 3x minus 2. Okay, that's step 1. Step 2 is to swap them. Swap the x's and the y's. So x is equal to y plus 4 divided by 3y minus 2. And right now, this is the equation x equals f of y. Right? That's what we've written. X equals f of y. And x equals f of y is exactly the same as y equals f inverse of x. So that's why by doing algebra, we can rearrange to get this equation that we're looking for. Okay, so what are the algebra steps to undo this? It's more complicated than what we just saw. You have to do a few more steps, but the principle is the same. You're just going to throw algebra at this thing until you can isolate y on its own. So I'm going to start by multiplying this 3y minus 2 out. 3y minus 2 times x equals y plus 4. And now I'm going to expand out this side. So 3y minus 2 times x is 3xy minus 2x is equal to y plus 4. Okay, and let's do a little line here, like that. And I'm going to move up here. So 3xy minus 2x equals y. I'm going to put all the terms that have a y on one side. 3xy minus y, and that's equal to 2x plus 4. So I took everything that had a y and I put that on the left. I took everything that didn't have a y and I put that on the right. So I moved the minus 2x from the left to the right. I moved the y from the right to the left. Then I'm going to factor out a y. So if I factor out a y, I get 3x minus 1 times y is equal to 2x plus 4. Okay, and last but not least, I'm just going to divide everything through to get y equals 2x plus 4 divided by 3x minus 1. And that is the answer. So this is equal to f inverse of x if you want. Okay, so by doing a sequence of algebra steps, what were the steps I had to do? I had to do exactly the set of steps to undo the function f, and that is exactly what f inverse is. Okay, so there you go. You saw that one with algebra. Any questions or comments about this one or the previous one? Solving them with algebra? This is, by the way, this is why we make you do the high school algebra quiz, so you can do problems like this. Yeah. Okay. So yeah, like everybody has kind of like doing these algebra steps will be personal to you. Maybe the way I did it is not so great for you, which is fine. And the other thing you got to watch out for, it's a lot easier to sit and watch somebody else do algebra than to do it yourself. So make sure when you're doing the practice problems, you practice doing it on your own and like really are able to do the algebra steps yourself. Like if I gave you just this guy, would you be able to think of multiplying by 3y minus 2? Or would that be a problem? Like this is something you got to practice. Okay, so let's do one more. Okay, now neither of them are frozen, so I guess I like that. Okay. Let's do one more, and the last one is part C, is the function ln of x. The function ln of x, and I'm going to need a new page for this, if it will let me, which it will not. Okay. Okay, we're going to pause for 1 second here while I restart the app. Okay. Okay, so what do we want to do is the function y equals ln of x. And if we do step 2 to this, we replace the x's and the y's, then x equals the ln of y. So by step 2. Okay, and once you've applied step 2, this is really the equation. This is x equals f of y, which is the same as y equals f inverse of x. So after step 2, you have reversed everything and you just need to isolate for y. So how do you get y on its own? You have to somehow undo the action of the logarithm function, this ln, the natural logarithm. And how do you undo the logarithm function? The answer is the exponential. So I'm going to do the exponential of both sides, exp of both sides. And then you get e to the x on the left-hand side. On the right-hand side, you get e to the ln of y. That's the exponential with base e. And ln and exponentials cancel out. That is just y. We're going to have more on the exponential later in the course, so more exponentials later. This is like a teaser for something we're going to do later. More exponentials and logs later. Okay, so what is the answer? The answer is f inverse of x is the function e to the x. That's what it is. So the inverse of the logarithm is the exponential. You probably knew that logarithms and exponentials have something to do with each other. Now you know what. Okay, questions or comments about this one? This one is a little bit less exciting than the previous ones. There weren't a lot of steps. You just sort of had to know how to undo the logarithm, which is what we, the final answer is, how do you undo the logarithm? So it's a little bit of a tautology. Questions or comments? Yeah. So ln stands for the logarithm base e. So ln is the special logarithm of base e. And the logarithm of some base always has this property that if you exponentiate it with that base, you get back what it started. In fact, that's the definition of the logarithm. So the logarithm of some number is the number, so that when you do the power, you get back the original thing. So for example, the log base 2 of 8 is 3. Why? Why is the log base 2 of 8 3? Because 2 to the power 3 equals 8, right? So because you take 2 to the power of the thing, you get back the original number, that means the log base 2 of the thing is 3. So that's exactly the property we're using here. And again, we're going to do more logarithms later in the course. So if you're like, you've heard of logarithms, that's great. If you're rusty on them, that's also fine. We're going to do more later. This is like a teaser for stuff coming up. Okay. Other questions or comments? Okay, let's move on. So exercise 81 is what we did last class, explaining that inverse functions and one-to-one go together, right? The only functions that have inverse functions are functions that are one-to-one. If you're not one-to-one, then you don't have an inverse function. So why does the function f of x equals x squared, why does it not have an inverse? Because it's not one-to-one. That's what we talked about last time. The next topic is we're going to do this f inverse stuff, but do it graphically. So from the graph of the function, what does the graph of f inverse look like? And this is all about keeping track of x, y pairs. So I'm going to pick a point. I'm going to pick the point 1, 3. 1, 3. So I'm going to do this point x, y equals 1, 3. And that's this purple point right here. And I'm going to imagine that I have a function that goes through this thing. So imagine I have some function, I don't know, maybe it looks like this. There's my function. And the function goes through the point 1, 3. And what that's saying is that f of 1 equals 3, right? xy equals 1, 3 is on the graph of the function, means that f of 1 equals 3. When you plug in x equals 1, you get y equals 3. If f of 1 equals 3, that translates into f inverse of 3 equals 1, right? F of 1 equals 3 says when you plug in 1, you get 3. F inverse of 3 says if you got out 3, then you put in 1. They're the same exact statement. So f inverse of 3 equals 1 means the point 3, 1 is on the graph of f inverse. So the purple point being on the original function is the same as the pink point being on the inverse function. And the thing to notice is they have the same coordinates but swapped, right? One of them is 1, 3. The other one is 3, 1. And this is totally true. The graph of the inverse function is you take all the coordinates for the original function, you just swap them. So that's what this thing is saying, this little paragraph. For example, if 1, 3 is on the graph of f, then 3, 1 is on the graph of f inverse. So they're exactly swaps of each other. The last thing to notice is that when you swap coordinates, that's exactly a reflection in the line y equals x. So here's the line y equals x, this line down the middle, and 1, 3 and 3, 1 are equally placed on either side of that line. They're reflections of each other around the line y equals x. So if you want to know what this purple function is doing, all you got to do is take the whole thing and think of reflecting that purple function across the line. It's going to look something like this. I guess it looks like that. And you can see the pink thing I drew is not exactly a function, right? The reason it's not a function is because the original purple function I drew was not one-to-one. So this is not a great example of doing it, but in general what you want to do is flip that purple function into the pink function. And there's some better examples on the next page. So let's go do the better examples. Here's the function f of x equals x cubed. F of x equals x cubed. So we're going to do exactly what I said, but on a real example, not just one that I just made up. And I'm going to start by just reflecting a bunch of points. And I'm going to start with these simple points, these points that are actually on the function, on the line y equals x. These don't move at all. So if you're on the line y equals x, then that point has the same x and y coordinate. When you swap them, it doesn't move. Points that are farther away, those will be different. So this point over here, point 1, 2 becomes this point over here. 1.5, 3. So 3, 1.5 becomes that point. This point over here, it goes up there, right? It gets flipped on the other side of x equals y. This point over here gets flipped down here. This point over here, negative 1.5, negative 3, goes to negative 1.5, negative 3. So it goes over here. And you can continue this on forever. And now I've given you a bunch of dots on the function. I just have to connect the dots. And what the function is going to look like is exactly this kind of thing, like so. So the original function kind of goes up and off to infinity, up this way, so the new function will go off that way. It's exactly a flip of the original function in the line y equals x. By the way, so this was the function y equals x cubed. It turns out that the inverse of cubing something, how do you undo cubing something? You take the cube root. This is the cube root of x. And in fact, we can just check in Desmos, that we did it right. So here's x cubed. And what would the cube root look like? Well, the cube root is x to the power 1/3. 1/3. So it should look like that. And you can see we've replicated the graph we had a second ago. There's a nicer version if you don't like mine. So the red curve is y equals x cubed, and the blue curve is the cube root of x. Okay, that was one example. Any questions about this graphical idea? Flipping across the axis y equals x. So you've seen with even and odd flips across the x and the y axis. Now we're talking about flipping across this diagonal line, which is a little different. Okay, let's do one more. This is the function e to the x. This is the function y equals e to the x. And of course, we already did the inverse of e to the x. It was ln. So this is the ln of x will be the other graph. But what does that graph look like? Let's figure it out by doing some points. So here's the point 0 across 1 up. So that gets mapped to the point 1 across 0 up. And here's the point 1 across and 2.8 something up. So that goes to 2.8 something and 1 up. Is that what I want? Yeah, 2.8 something and 1 up, right? There we go. Flipped across the axis. Here's the point -1, and you have, I don't know, it's like a little decimal something. It goes over there. Did I do that right? No, that looks wrong. That looks wrong. So -1 over point something up. So then I go down -1 over point something up. Okay, there we go. A little better. Blue, -3, somewhere over there. And so I go -3 and I go somewhere down here. Okay, so now I think we're ready to connect the dots. What does this function look like? It's going to connect all these, and then it's going to keep going in that direction and keep going down forever. And that is a graph of the function, the logarithm function, the ln of x. So exponentials grow forever. Logarithms also grow forever, but they have this vertical asymptote at x equals 0. And we can check again, if you want to check these things, you can check e to the x looks like that, and the ln of x looks like that. They kind of mirror each other in the line y equals x down the middle. Okay, fancy version of what's in your notes. Okay, last one is an example where you take the function f of x equals x squared and we try to flip that. So what would that look like? This point is the same. This point is the same. This point gets flipped over there. This point way up here gets flipped over here. This point, -1, 1, becomes -1, 1. This point all the way up here, -1, 2. So it becomes 2, -1, something like that. Okay. And I think we're ready to connect the dots. So it goes like this, connecting these like that. That's the first little bit. And then the function turns around, right? It goes from this dark green to the light green to the red, and it keeps going. Keeps going. So the thing you get by taking the parabola and flipping it across the axis is this sideways parabola. And the thing you should notice about this sideways parabola is it not a function. Not a function. Why is it not a function? It fails the vertical line test. So in fact, these points that I've drawn have the same x value but two y values, so it fails the vertical line test. And why does it fail the vertical line test? Well, it's actually because the original function fails the horizontal line test, right? The horizontal lines and the vertical lines have traded places. So the reason the thing is not a function is because it failed the vertical line test. Why did it fail the vertical line test? Because the original guy failed the horizontal line test, and that happened because this is not one-to-one. Not one-to-one. So there you go. This is really doing that example of if it's not one-to-one, then it's not invertible. I'm doing that in a picture form. Any questions about that one? Okay, the next little topic is what we've been talking about all along, is how functions and inverse functions, they undo each other. And we're talking about that using this circle, which is the composition, right? So composition means apply one function, then apply the other. And if you apply f and f inverse together, then they are going to undo each other. So what do you get if they undo each other? Well, if you feed it x, you get back x. So if you feed in f of f inverse of x, you just get x. And this works for every x in the domain of f inverse. And if you do f inverse of f, you get back x as well. So the composition of a function and its inverse is just the original thing you started with. Sometimes this is called the identity function. So the function I of x equals x is called the identity function. It's the function that does nothing. Whatever the input was, the output is the same. So let's see a couple of these examples, and they have a few examples here, most of which are quite simple. So here is the example. If f of x is x plus 5, the adding 5 function, then what is f inverse? It's the subtracting 5 function. And what we're about to figure out is what happens to a number if you add 5 to it and then you subtract 5 from it. Well, I think you guys will figure it out. Let's do circle f inverse of x. So f of f inverse means first do f inverse, first subtract 5, and then do f. That means then add 5. So try to keep track of what do you think is going to happen if you add and subtract 5. So f inverse of x is x minus 5. F of x is whatever it was inside of it, we add 5. And so at the end of the day, we're left with x minus 5 plus 5, which is just x. Okay, big surprise. You subtract 5, you add 5, you get back where you started. You get back x. Let's do another example with the x cubed function. And the inverse of the x cubed function is the x to the 1/3 function, the cube root function. So let's see how this one works. Cubes and cube roots. Let's do this in blue. So f of f inverse of x. F inverse of x is x to the 1/3, and we're applying f to that. And f is the cube function, so it's x to the 1/3 cubed. And you have to know your exponent rules. If you have an exponent to another exponent, the exponents multiply. So you have x to the power 1/3 times 3. And what is 1/3 times 3? It's x to the power 1, also known as x. So that's another way that you can see that cubes and cube roots undo each other because exponents multiply. Okay, you can do a few more of these. They give you one more example, which is we already did, the log function, right? Exponentials and logs undo each other. I'm not going to do that one. So I'll leave C as extra. And again, we're going to do this when we do logarithms again. And I think on the next page, there's a harder one for you to do if you want. You can try this function. Let me freeze that. You can try this function, x plus 4 over 3x minus 2, and 2x plus 4 over 3x minus 1 that we did before. So if you want extra problem to try on your own, you can do that. Okay. Any questions or comments about inverse functions? That's all we're doing for inverse functions. We're going to move on to a slightly new topic. Okay, so the next section is 4.10. 4.10, which is about function transformations, transforming functions. And so if you have a function that you know very well, maybe you have a nice picture of its graph, how can you tweak that picture to make it do something else? And the first thing you can do is you can do vertical translations. Let me show you what vertical translations look like as a picture and as algebra. So if you add a constant, you do plus c, then you're taking the y values of the function, you're adding something to them. You're adding plus c, you move everything up by c units. That makes sense because, plus 2 is up by 2, minus 2 is down by 2. It makes perfect sense. So let's see what this looks like. And what I got to do is do this. Okay, here's the function y equals x squared. And here is the function f of x plus a. F of x plus a. So in the notes they called it a. Is c, I'm calling it a. F of x plus a, but right now a is 0. And what happens if I hit the play button? Desmos will start adding stuff to a. So a, now it's 2, now it's 3, and you can see we're moving up. So you add to the function, you go up. Here we're subtracting. What happens if you subtract? Well, you go down. Okay, not very surprising. So what we've just done in Desmos is a picture version of what's in the next page on your notes, right? The animated version. If f of x equals x squared is the dotted line, then how would you shift it up by 2? You would do x squared plus 2. And how would you shift it down by 2? You would do x squared minus 2. All very straightforward. Adding 2 is up, subtracting 2 is down. Here is where it gets exciting, and I'm going to have you guys do it on Mathmatize. The exciting thing is, what happens when you do f of x plus 2, but the plus 2 is in the brackets? You do f of x plus 2 first, then apply f. then we're going to shift somewhere, but is it up, down, left, or right? And you guys think about it, decide what you think it's going to be. Maybe you remember from high school, maybe not, and I'll reveal in a minute the answer. Okay, let's see what you guys said. Is it up, down, left, or right? Hopefully nobody picked up or down because we already know how to do up and down. It's different. So up and down are not right. If you want to do up and down, you put the plus and the minus outside the function. It's going to be left or right. 41 people said left. 27 people said right. So pretty split between left and right. How are we going to answer this question? Of course, the only way is to do it in Desmos. So here is f of x plus c. I'm going to make c 0 to start. F of x plus c is here. I'm going to press the play button, and then Desmos will start moving the function. You got to say, is it going to move to the left, or is it going to move to the right? So here we go. 1, 2, 3. Oh, okay. So it was left. It goes to the left. So how many people got it right? Like 60%? 56% to 37%. The correct answer is left. Probably if you got it right, you remember from high school, it's this counterintuitive fact that if you're doing stuff inside the function, it kind of does the opposite of what you would think. So adding is plus on the y-axis, but when you add inside here, it moves it towards the negative, to the negative numbers, right? So even though c is 5.22, here I'm at negative 5.22. And if you keep going, if c becomes 10, then we're at x equals negative 10. It does the opposite of what you would think. So that's very important to write down correctly. And here it's written correctly. So f of x plus c is moving to the left. F of x minus c would be moving to the right. Here's the picture. So if you want to move to the right by 2 units, you got to do right by 2 units. You got to do x minus 2 squared. And if you want to move to the left by 2 units, you got to do x plus 2 squared. It's kind of the opposite of what you would expect. Questions or comments about that one? Okay, the next thing we're going to do is reflections. Reflections. So same thing as before. There's 2 types of reflections you can do. There's vertically or horizontally. And the question is which is which. So if you put the minus sign one place or the other place, you get one or the other. Which is which? So another 2 minutes, you guys can tell me what you think it's going to be. Okay, there's a minute left, but I think there's only like 5 people who haven't answered yet. So if you're one of the last 5 people, put your answer in, and then we can stop. We can do this a little early. Okay, I'm satisfied with 64 people. Let's see, 65. Okay, I'm stopping it. Reveal counts. Who said what? So the first one, minus f of x. By a split of 40 to 27, you guys voted for vertically. Minus f of x is vertically. So to find out, let's look at minus f of x. I have this Desmos open. And here is the function minus f of x. When I press this button, it's going to reveal what it is. Here we go. Boom. Okay, is that horizontal or vertical? That is vertical. Look, see? The little down peak got made into an up peak. This little funny going down and this is funny going up are opposites of each other. The correct answer is vertically. Vertically. And again, the way you can tell is if you do stuff outside of f, if you do stuff outside of f, that is messing with the y values. And if you mess with the y values, that's a vertical flip. If you do stuff inside of here, that is messing with the x values. So that's going to be horizontally. So minus f of x flips it vertically. F of minus x flips it horizontally. Let's fill that in on our notes really quick. So exercise 89. How do we flip it vertically? That is minus x squared. Flipping vertically is reflecting in the x-axis. You have to be a little careful. At least my brain, like it hurts a little bit when I say vertically is x-axis, right? But we're flipping around the x-axis. That's a vertical flip. And the opposite of that is flipping horizontally, which is, for some reason, 3 pages from now, I don't know why. Reflecting in the y-axis, this is a horizontal flip. So it's minus the square root of x. So you take the function, you flip it horizontally. That is, no, I lied. It's not minus f of x. It's the square root of minus x. Okay. So what does this look like? I will show you in here. So here is f of minus x is the opposite, is doing it like that. It's taking it and flipping it along the y-axis, flipping it horizontally. Okay. Next class, we are going to learn a very cool thing that I like a lot, which is how do you animate this funny thing? Going between, how do you animate flipping the function? We're going to learn about this ghostly red curve and how it kind of goes between flipping it and not. And then, we're also going to learn not even that one, but also this one, right? How do you flip between vertically? How do you flip it like that? I think these are cool to look at. I don't know. Yeah, enjoy your weekend. We'll see you guys on Monday. Yeah, give me 1 second.